Welcome, and thank you for joining us ahead of the launch of Hugo, our third satellite. Over a year ago, who could have thought we'd be where we are today? Life has gotten very complicated for all of us with the global pandemic. But we've all been resilient. We've all come through, and after all, it's actually been a pretty good year for GHGSat. Our team pulled together and brought our company to new heights with the launch of our previous satellite, IRIS, as well as to some virtual heights with the launch of our new global methane website called Pulse. And we look forward to this launch now of GHGSat's new satellite, Hugo. So I want to take this opportunity to say thank you. And thank you to all of you, our customers, our partners, and our team in making this year and next year and the years to come a success. So despite these extraordinary circumstances, we're proud to be part of an industry that takes on big challenges and brings those to a success. So some examples this year, some really exciting examples, include SpaceX's launch of the Crew Dragon capsule, China's launch of Chang'e 5 to the moon to bring back samples for the first time in many years, Canada's participation in OSIRIS-REx, a sample return mission from the comet Bennu. So now I want to talk to you about some of the highlights we had in 2020 as we lead up to the launch of our next satellite, Hugo. One of our greatest achievements this year was the launch of IRIS, our second satellite. IRIS is the culmination of years' worth of efforts that ultimately took only 40 minutes to get from ground to orbit to start delivering some of those amazing results we've seen to date from our technology. IRIS is the first of a constellation of new satellites that will enable us to measure methane and carbon dioxide point sources around the world. We look forward to working with our customers and partners to bring on new capabilities, new capacity, and to provide new impact in the fight against climate change. Within the first week after launch of IRIS, we generated our first light image. So this was the first plume that we detected from Central Asia using our new satellite. We were very excited about how fast we got these results and how clean those results were for just 1 week after launch of a new satellite. Within 2 weeks of launch of our satellite, we had what we call our first results. And this is the first confirmation of the detection threshold of our new satellite. And we did that by doing a controlled release, which is releasing a known amount of gas and measuring that from space and confirming that the two measurements match. So then again, was exciting because it proved that we were now achieving the results that we'd set for ourselves, the objectives that we'd set for ourselves with our new satellite. GHGSat's continuing success and the performance of our sensors and our analytics for interpreting the data generated from our sensors to produce insight for our customers generated new enthusiasm from our investors and enabled us to attract new investors to raise a new round of funding. That new round of funding, Series B, was worth $30 million The Series B was led by Investissement Québec with the support of the Business Development Bank of Canada, the Oil and Gas Climate Initiative, the Fonds de Solidarité des Travailleurs du Québec, Space Angels, and Schlumberger. The money that was raised will be used for increasing the capacity of our system and increasing the analytics to interpret the data generated by our sensors. This new investment is enabling us to invest in several new satellites. And just this September, we announced a new contract with ABB to generate the payloads for those satellites. In addition, this new investment is also enabling us to invest in analytics and expanding our analytics capability both in Canada and in the United Kingdom. So not only does GHGSat operate satellites, we also operate aircraft sensors, and they operate at 2 different altitudes because they complement each other. The satellite operates at about 500 kilometers altitude and provides sustained coverage over large areas. The aircraft sensor operates at lower altitude to provide higher resolution and lower detection threshold measurements over specific regions or for specific customers. So we operate both of these as complements to each other to offer a better service for our customers. So at this point, I'd like to hand it over to Warren Shaw, our Manager of Aircraft Systems, who will describe in this podcast segment how the aircraft sensor works.
It's still the same kind of fundamental imaging spectrometer system based on our patented Fabry-Perot system. The light comes in and you have a 2-dimensional imaging array. And so you have the 2 spatial dimensions, but kind of imprinted on that is that spectral information. So we're looking at a very narrow spectral band. That's obviously where methane will absorb the solar illumination on the ground. As we image, the strength of that absorption feature then is proportional to the abundance of methane in your field of view. So at the heart of it, it's using all that same kind of technology. So as you have that 2-dimensional image of the ground and the forward motion of the satellite or the forward motion of the plane, you can image the same ground point at different points on the detector, which in turn is sampling that ground point at different wavelengths, and you can build up that hyperspectral data cube.
The successful launch of IRIS, the results from the satellite, and our new funding announcement led to widespread media coverage. Also this year, our team was fortunate and proud to be recognized by a number of different associations and groups with awards for the performance and for our achievements as GHGSat. So at the beginning of the year, we were recognized by the World Economic Forum as a technology pioneer, and we were invited to attend their annual meeting in Davos. Later in the year, we were recognized by Bloomberg as a new energy pioneer. After that, we were recognized by World Satellite Business Week as a pioneer in Earth observation. And finally, at the end of the year, we are recognized as Company of the Year by Techterra. All of these are a testament to the quality of the work and the achievements done by the team at GHGSat, and I'm incredibly proud of our team. And here's what they have to say about GHGSat.
Today, I'm excited to celebrate the winners of the 2020 Techterra Awards, the people and companies that are leading the way in geospatial technology in Canada. I'd like to thank our volunteer judges and extend my congratulations to all the people and companies that were nominated. We're proud of everything you've accomplished in 2020.
The Company of the Year category salutes the leaders who create best practices and set an unmatched example for the industry. The nominees in this category are setting benchmarks across a range of industries and made some incredible accomplishments in 2020.
And the winner is GHGSat. GHGSat is a global leader in high-resolution greenhouse gas monitoring from space. They've recently launched a new satellite, IRIS, with technology that detects emissions from sources 100 times smaller than any other satellite system. Congratulations, GHGSat.
When we founded GHGSat, we set out to bring space down to Earth. We set out to bring the science and the wizardry of satellites and space to the service of everyday needs here on Earth. Part of that was to make some of our data public. So at the World Economic Forum's annual meeting in Davos in January 2020, we made a commitment. We promised to make global methane data available on a worldwide basis for free at a higher resolution than has ever been available before. And we delivered that. In October of 2020, we delivered Pulse. Pulse is a global methane map that is available for free on GHGSat's website, is updated weekly, and provides resolution down to 2 by 2 kilometers. That is higher resolution, both in space and time, than has ever been available before. Within 48 hours of launching Pulse, we had over 9 million requests for information to the database behind the map. That's huge, and we're really proud of the level of interest that our map has generated. And that's just the beginning. The next step after Pulse providing concentration information worldwide is to provide emissions information worldwide. And the difference is that emissions will enable us to understand the rate at which concentrations are changing and provide regional, jurisdictional, or even company level estimates of emissions worldwide using this new and more advanced version of Pulse that we want to make available in 2021. Collaboration is very important to GHGSat. We can't achieve the ambitious results we want to achieve with GHGSat without working with experts from around the globe. So we partnered with groups like Harvard in the United States, with ESRON in the Netherlands, with the European Space Agency, the Canadian Space Agency, NASA, and others. One great example of this is how we use a European Space Agency satellite called TRPOMI Sentinel-5P to provide methane information that is then incorporated with our own data into our global methane map, Pulse. But that's just one example. Recently, we published a paper on how we can also use another European Space Agency satellite called Sentinel-2 to provide global coarse measurements of greenhouse gas emissions from individual facilities. Combining all these capabilities provides us with even better information to translate into services for our customers. Today marks another huge step in the deployment of our constellation. Today we launch Hugo. Hugo is the third satellite in our constellation, which together with its existing sisters, Claire and Iris, and future satellites, provide emissions monitoring services for industrial facilities everywhere in the world. Hugo is the size of a microwave oven, weighs about 15 kilograms, small but mighty, and delivers 100 times better resolution than any other satellite in space or planned today. Now, why Hugo? Why the name Hugo? It's because we decided when we first started the company that we wanted to remind ourselves of why we do the work that we do. We want to name our satellites after our children. Claire, Iris, and Hugo, and our future satellites are named after our children to remind ourselves of why we do what we do. And here's how Hugo will be working with Claire and Iris to support our mission. So 2021 is kicking off in a big way for GHGSat. We're really proud of everything we've accomplished. I'm very proud of our team. We're thrilled to have the partners we work with, the investors that believe in us and are encouraging us to grow our business. We're accelerating our growth, attracting new customers, delivering new satellites, all at once. To emphasize this acceleration and the maturing of our business, as we deliver services to oil and gas, waste management, coal mining, agriculture, power generation, financial services, and other sectors that want and need greenhouse gas information. We're taking the opportunity to relaunch our brand. We want to show the world our sense of optimism and hope for what we think we can achieve with GHGSat and together with our customers and partners in making an impact on climate change. So there's just a few minutes to go now before we cut over to the live SpaceX feed. But before we do, here's a message of support.
As the president of the Canadian Space Agency, I am proud to see a Canadian company that we supported in its early years achieve commercial success, especially when it's providing satellite data that can help monitor climate change and better understand the planet. Congratulations, GHGSat, on all your achievements and on developing and launching Hugo, your third greenhouse gas emissions monitoring satellite. I wish you every success in the future.
And the last word goes to the team as we count down towards launch.
Safe travels, Hugo.
Oh, Hugo!
Have a safe trip, Hugo.
Bonne chance, Hugo.
Bye, Hugo.
Bon voyage.
Godspeed, Hugo.
Go, Hugo!
Happy trails, Hugo!
Hey, Hugo!
Allons-y, Hugo.
Space!
May the force be with you, Hugo.
Viva Hugo.
Good luck, Hugo.
And now, we hand it over to SpaceX. Thank you very much for joining us. I'm Stéphane Germain, the CEO at GHGSat.
LWO1 WeatherNet. Liftoff conditions looking pretty good.
ESPS is ready for launch.
Ignition. Liftoff.
Falcon 9 has cleared the tower.
Ten, 9, 8.
Side booster ignition.
6, 5, 4, 3, 2, 1.
Good morning. It's Saturday, January 23rd, and we're here at SpaceX's headquarters in Hawthorne, California. You're looking at a live view of Falcon 9 as it awaits its 9:40 a.m. Eastern Time launch from Cape Canaveral Space Force Station in Florida. My name is Andy Tran, and I'm a production supervisor here at SpaceX. Welcome to the webcast for SpaceX's Transporter-1 mission. It's our first dedicated small-sat rideshare program launch and third launch of 2021. On board this mission are 133 commercial and government spacecraft, in addition to 10 Starlink satellites, the most spacecraft ever deployed on a single mission. This count includes CubeSats, microsats, and 2 orbital transfer vehicles, sometimes called space tugs, which would deploy their spacecraft after separating from Falcon 9. SpaceX created the SmallSat rideshare program to provide SmallSat operators with competitive pricing, increased flight opportunities, flexibility, and most importantly, a ride to space on SpaceX's Falcon 9, Falcon Heavy, as well as Starship in the not-too-distant future. For more details on our rideshare program or to reserve your spot, head over to our website at spacex.com/rideshare. Now let's take a look at Falcon 9 out on the pad at the Cape. You're looking at a live view of Falcon 9, our 70-meter, two-stage liquid-fueled launch vehicle. Today's mission is the 5th flight for this particular booster. Its first 4 flights were all in 2020 and included our Crew Dragon Demo 2 mission for NASA in May, the Anasis 2 mission in July, a Starlink mission in October, and most recently CRS-21 in December. You can tell by the re-entry soot at the bottom of the vehicle that this booster has flown before. That bottom 2/3 of the vehicle is the first stage. Its objective is to accelerate the vehicle through the Earth's atmosphere into space and then separate from the rest of the rocket. From there, it will make its way back to Earth and target a landing on our recovery vessel, Of Course I Still Love You, which is our drone ship in the Atlantic Ocean. There it is on screen. On top of the first stage is the black carbon fiber inner stage. This is a composite material and it houses the larger nozzle of the second stage engine. Then on top of that is the payload. Then on top of the inner stage is the Falcon 9 second stage, which takes the payload to its eventual destination in orbit. After the first stage separates about 2.5 minutes into flight, the second stage will then carry the 143 spacecraft to orbit. And in order to get the intended orbit today, we'll need to light our second stage twice before deploying all of our payloads. At the very top of the rocket, you'll notice a large nose cone. This is called the fairing. It's a composite structure and protects the rocket from the forces of ascent and houses the payloads. Once the vehicle is outside of the Earth's atmosphere, the fairing separates to expose the satellites to space. For today's mission, our fairing is brand new. Our recovery vessel, Miss Chief, there it is on screen, will be attempting to recover the fairing halves from the water following landing. And finally, the large truss structure next to Falcon 9 is called the Transporter Erector. We also refer to it as the TE. Its job is to roll Falcon 9 out to the launch pad, raise it to a vertical launch position, and also route power, fluids, and communication to both the rocket and the satellite. It will retract away from the rocket slightly at around the T-minus 4.5 minute mark, providing clearance for Falcon 9 to lift off. The chief engineer held a technical poll at T-minus 1 hour mark, and the launch director held a propellant load and launch go-no-go poll at the T-minus 38 minute mark. If we do have a call to hold today's launch, we do have a backup opportunity tomorrow at 10 a.m. Eastern. We are currently red on weather for surface electrical fields. We'll keep a close eye on that as we count down, but weather is looking a little dicey for our current liftoff time. Falcon 9 has been loading propellants since the T-minus 35 minute mark. The vehicle uses a refined form of kerosene called RP1 for its fuel and super chilled liquid oxygen, or LOX, as its oxidizer. Currently, RP1 is fully loaded on the second stage and nearly fully loaded on the first stage. Liquid oxygen loading is currently underway as well. Helium load also began before the webcast went live and will continue to top off until 1.5 minutes before launch. We use this helium to pressurize the tanks as the propellant is pulled out by the engine pumps. In about a minute at the T-minus 7 minute mark, engine chilling will begin. This is where we allow a small amount of super chilled liquid oxygen to flow into the Merlin engine turbopumps prior to the full flow of LOX to avoid any thermal shocks to the system. And then a few minutes from now, checkouts of the second stage thrust vector control actuators will be underway. This is also known as the engine wiggle test. We move the thrust chamber slightly to make sure that the guidance hardware is a go for flight. This happens on the first stage engines as well, and those happens just seconds before ignition. The vehicle is healthy and we are currently working no issues. The range is standing by to support. Again, the weather is red, but we'll continue to monitor that all the way until T0 to see if we get a chance for liftoff today. All systems continue to go for a liftoff at 9:40 a.m. Eastern Time. Just getting word from the team, so it's official. We are scrubbing today for weather, for surface electrical fields. We do have a backup opportunity tomorrow at 10 a.m., so we'll see you then and attempt another launch for Transporter 1.
Stage 1 RP1 load is closed out.